All right, so today we are continuing at chapter 4. We are on day 8. In your notes, it says 4.8 at the top. It's all about distance problems. Everybody ready? Have your notes? Know where we're at. Okay, great. The first thing we need to talk about is the distance formula. So write this in your notes.
Where?
Off to the right, you have a big space. Write this. D equals R times T.
Time.
This stands for distance equals rate times time. So the D is distance, the R is rate, and the T is time. Any questions so far? All right. Now this part is in your notes, right? Okay.
Dot line.
So when we are talking about opposite directions, that's where two things start at the same point, and one is going one way, and one is going the other way.
Parallel.
Okay? We will also look at problems where two things are going in the same direction. And then round trip means you go one direction, you turn around, and you come back. Okay? So 3 options. 2 things are moving in opposite directions. 2 things are moving in the same direction. Or you can talk about a round trip. You go there, you come back. Like a round trip vacation, you fly to Florida, you fly back. Any questions so far? Example 1 says, what is the distance traveled in 6 hours at 60 kilometers per hour? So the distance formula, distance equals rate times time. What do we know? We know what?
The rate of time.
We know the rate. The rate is 60 kilometers per hour. We also know the time. It's 6 hours. So you plug in the numbers you know, and hopefully the one you don't know is also the one that you're looking for. It asks us what is the distance, and D is the only thing I don't know. So you can go ahead and do 60 times 6. It's 360. We were driving kilometers per hour. The answer is kilometers. What are your questions so far? Next, example 2. What is the average rate of speed if 275 kilometers are traveled in 5.5 hours? Same starting point. Distance equals rate times time. What do I know now?
Distance and time.
I know the distance and I know the time. So take the D out, put the 275 in. Take the T out, put the 5.5 in. I am solving for rate. So the way you would solve this is you divide both sides by 5.5. So we get 50 kilometers per hour. Rate is always the units that you're traveling and how long it takes. Kilometers per hour. Questions? All right, here's number 2. Mo and Curly leave school traveling in opposite directions. Mo is walking, Curly is biking, and averages 6 kilometers per hour more than Mo. If they are 18 kilometers apart after 1.5 hours, what is the rate of each? So, this little dot, I'm going to draw a little diagram. This little dot represents the starting point. That's the school, okay? One's going one direction. That's Mo. Curly's going in the other direction. Like the Three Stooges, Mo and Curly.
I was gonna say, is that just coincidence that it's small?
Nope, I don't think so at all. Okay, so if we call Mo's speed R, what would we call Curly's speed? Yes.
R plus 6.
R plus 6, because he is averaging 6 kilometers more than Mo. Okay, so if Mo is traveling R, that's the rate, right? His speed is the rate. Curly is traveling 6 more than that. So R plus 6. Okay? What else do I know? The time, 1.5, and the distance. So that entire thing is 18 kilometers. So when you find total distance, it's the distance of each of them. So we need to take the distance that Mo travels plus the distance that Curly travels. That will give us the total distance apart. In this case, the total distance is 18 kilometers. All right, so I'm going to use one of those boxes. We called Mo's rate R. We called Curly's rate R plus 6. Do you remember what the time was? 1.5. They both travel for 1.5. So 1.5 hours. Mo's traveling at R rate. Curly's traveling at R plus 6. Distance is rate times time. So R times 1.5 and R plus 6, but you're going to have to distribute, right? So this is just rate times time. So his rate times the time, but we always write the number in the front, right? So 1.5 hours times his rate, 1.5 hours times his rate. But we have to distribute because he's going faster. And that we want to equal 18 kilometers. That's the total distance apart. So what do you think I'm going to add? Wow. That's how my day's been going. I wanted to say, what do you think I'm going to do with these numbers? But instead I said add. So there's my question and my answer. We need to add the distances together and get the 18. Okay? So 12.5 R, that represents Mo, plus the 1.5 times R plus 6, that represents my Curly. And then that needs to equal 18 kilometers apart. All right, how would I solve this? Yes, you distribute the 1.5?
Yes.
Wait a second. Is there a spot in your nose to solve it?
No.
So here's your equation, right? And what did we say we were going to do?
You were going to distribute the
Distribute. Good. So I have 1.5 R plus 1.5 R. What's 1.5 times 6? 9. 9. It's like 1.5. So you have 6 plus half of 6, which is 3. All right. We're just going to finish this guy off. So what's 1.5 R plus 1.5 R? 3R plus 9 equals 18. Then what? Subtract 9 from both sides. Good. And then you want to... Good. So R equals 3. Who was was traveling R?
Well,
Mo. So Mo's rate is 3. What are we talking about? Kilometers per hour. And then Curly was what?
It is 9.
Because you had 6.
Yeah, so remember we were calling Curly R plus 6. So 3 plus 6 is 9. You have to make sure that you actually are answering the question, okay? If you just say R equals 3, you're not going to get all the points. That's only half the answer. You don't want to do all this work for half the credit, right? When all you had to do was add 6. So be real careful on that. Any questions? So we have 2 guys, right? They're leaving from the same spot. Are they traveling in opposite directions or the same direction? The same direction. Okay, so Travis starts first. He leaves 20 kilometers per hour. 15 minutes later, Nick leaves. He's trying to catch up, so he's driving 24 kilometers per hour. Or biking, I guess. Okay, here's where it gets a little tricky. However long it takes till they're together, Nick lost 15 minutes, right?
yeah.
Like if it takes them an hour to catch up with each other, Nick only got to bike for 45 minutes. If it takes them 2 hours, Nick only got to bike for 1 hour, 45 minutes, right? 15 minutes is a quarter of an hour. So whatever the total time is for them to get to the same spot, we have to subtract off that 15-minute head start that Travis got that Nick did not get. Okay? So whatever the total time is, we have to subtract that head start from Nick because Nick didn't get to ride his bike during that time. Okay? And 15 minutes is a quarter of an hour. And since it's kilometers per hour, everything needs to be in terms of hours. So do you all understand why it's T minus 1/4? That's the 15-minute head start that Travis got that Nick did not get. Okay? They are going in the same direction. And we want their distances to equal one another. When will he catch up with him? So when will the amount that they traveled be the same? All right, any questions? So, let's try to fill this in. Travis's rate is
20 kilometers an hour.
20 kilometers per hour. Nick's rate is 24 kilometers per hour. Travis travels for how long? T. Nick travels for T. Take away 1/4 because that's the 15 minutes. Good. And if you're ever unsure what the fraction is, put the number of minutes over 60 and reduce. 15 over 60 is 1/4. So for Nick's distance, we would multiply these two. These two. For Travis's distance, we'll multiply these two. All right, so we have 20T for Travis, 24 times the quantity T minus 1/4 for Nick. That's just the rate times the time for each of those. And we want to know when they're at the same spot. So we want their distance to equal each other, right? Make sense? So this is the equation that we need to solve. All right, how do I solve it? Yes?
Distribute 24 to t minus a quarter.
Good. So we have 20t on the left, 24t minus 6. It's like 24 divided by 4. That's, if you're like, how'd they do that so quickly? All right. Then what?
Subtract 14.
Okay. 20t minus 24t is negative 4t equals negative 6. Now, I'm going to contradict myself because usually I say leave it improper, right?
Yeah.
Would you ever go up to someone and be like, I'll see you in 3/2 of an hour?
All the time.
All the time. What would you say?
1.5.
1.5 hours. Good. So you can write it 1.5 hours. You can write it 1.5 hours. You can write it 1 hour, 30 minutes. Those are all the same thing in my book, okay? I will double check with the other Algebra 1 teachers to see like how we write it on the final. I honestly prefer this, but it's really good, I think, if you know that all three of them are the same. So at this point, whatever form you want, go for it. Don't do 3/2 hours. I don't know what that means. Questions? All right, let's check out number 5. Tyler and Steven leave basketball practice at the same time. They're going in opposite directions. Travis travels at 80 kilometers per hour and Steven travels at 72 kilometers per hour. How many hours will they be 760 kilometers apart? So we're going in opposite directions, right? We got Tyler going one way, 80 kilometers per hour. We got Steven going the other way, 72 kilometers per hour. We want that total distance between them to be 760. What do you think I'm going to do with each of their distances to find the total? Yes.
You're gonna make a variable for like time, and then do like 72.
So add them. Yeah, so we're going to end up adding Steven and Tyler's distances to equal 760 is going to be the game plan. Okay? So D Tyler, that stands for the distance of Tyler, plus the distance of Steven is the total distance that they are apart.
So we just
All right, let's get our chart going. Tyler is traveling at what rate? 80. Steven is traveling at what rate? 72. They start at the same time, right? So however long they travel is going to be the same for both of them. No one got a head start. So T and T. So the distance for Tyler is just 80 kilometers times however long it takes. The distance for Steven is 72 kilometers times however long it takes. And once again, we need to add those to be 760. All right. The fun part. How do I do it?
152 squared.
Not t squared, just t. When you combine like terms, don't change the exponent. Don't mix the rules from the different chapters. Combining like terms, you just add or subtract the coefficients. All right, so 152t equals 760. Divide, divide.
I got equals 1.01.
So,
I got some big one.
let me double check. So 760 divided by 152. I got 5. What'd you get? Oh, you were scaring me. I was like, oh my, how are we going to make that into minutes? Yeah, just 5. 5, talking about time, so hours. You scared me. It's like, uh-oh. Here we go. All right. Any questions on Stephen and Tyler?
No.
All right, we have one more, right? One more in your notes? We cannot. At 8 a.m., Kristen leaves home to go shopping. She was driving at 35 miles an hour. Speed it up, Kristen. At 8:30, her mom discovers that Kristen forgot her purse. She drives 50 miles per hour to catch up with Kristen. Her mom is delayed 15 minutes with a flat tire. Wow. When will her mom catch up with Kristen?
She has a flat and she's driving.
She has a flat and she left a half hour later.
And she's driving 50 miles.
Yeah. Okay, so let's just see what we know. Same direction or different directions?
Same.
They're going in the same direction. Okay, Kristen leaves. She's going 35 miles per hour. Left at 8 o'clock. Mom leaves 50 miles an hour. Left at 8:30, but then has to stop for 15 minutes. It's a lot of info.
So 45 minutes.
Right. So she is delayed 45 minutes. Does anyone have a fraction in their head? Yes. 3/4. 45 minutes is 3/4 of an hour. If you're not sure about that, in your calculator, do 45, ABC button, 60, because there are 60 minutes in an hour. Hit the equal sign. It will do it for you. Okay? So if we call Kristen's travel time T, we'll have to call her mom's travel time T, take away that 45 minutes, which is 3/4 of an hour. How are we feeling so far?
Horrible.
Horrible? All right, and we want to know when they get to the same place. So we need their distances to equal one another. Any questions? All right, so what's Kristen's rate? 35. What's mom's rate? 50. What's Kristen's time? If you called it, well, I wouldn't call it R because that'll make you think it's right. But yeah, so we're going to call Kristen T, and then whatever that time is, you got to take that 45 minutes off of the mom's. So T minus 3/4, 3/4 of an hour, 45 over 60. So Kristen's total distance, you just multiply those two, 35T. Mom's distance, 50 times the quantity, T minus 3/4. And I want to know when they'll be at the same spot. So when will her distance equal her mom's distance. What are your questions so far? All right, that's where we want to start. What should I do first? Distribute the 50. So 35t equals 50t. When you multiply these, you get 150 over 4, which reduces to 75 over 2.
Which equals 37.
Which is 37.5 or 37.5. Any of those is fine. Let's just leave it like this until we see what happens, okay? We multiplied 50 by 3/4. We distributed the 50. 50 times t is 50t. 50 times 3/4. So 50 times 3, 1 times 4, and then we reduced. All right, let's get those t's together. So I'm going to subtract 50t from both sides. What's 35t minus 50t?
Negative 25t.
Careful. Negative 15t. All right, now what should I do? Divide both sides by negative 15. It's kind of weird over there. You might want to think of it as multiplying by 1 over 15 negative, right?
Can I do it to 37.5?
Yeah, honestly, I have a calculator, so I'm just going to type in divide by negative 15 because the answer was already in my calculator.
What'd you get?
Anyone have an answer? 5 over 2, which I am actually...
I'm getting negative 0.25.
Hold on. Shh. You shouldn't get a negative because we divided a negative and a negative. 5 divided by 2 is 2.5. I'm talking about hours. So don't tell me 5 over 2 hours. I don't want to have to sit there and look at a clock and think of like, well, how many half hours is 5 hours?
This is complicated.
Don't do it, okay? Either put it as a decimal or how many minutes is a half hour?
30.
So you could also say 2 hours, 30 minutes. Any questions? If you were doing this by hand, just a little side note, from right here, this would be negative 75 over 2. You would make the 15 a fraction and flip it, right? So it would look like this. And you'd end up with 75 over 30, and then you'd reduce, okay? So careful if you're going old school, no calculator. It is possible. That's how you would have to tackle those fractions. Any questions? All right, here's our summary. So what did we talk about today? Yes? Distance problems. I'm actually just going to put distance equals rate times time. Just sum it all up in one quick little formula there. All right, here comes your homework. You have about 9 minutes to work on it, and then it is homework, so you're going to need to do it over the weekend.